You are asked to determine the relative index NL of a transparent liquid using the apparent displacement of the image of an object. You are provided with a tall cylinder, sufficient amount of liquid, a travelling microscope, a small pin or fine plastic piece which can float on the liquid, and large syringe. Part A. Write an expression for the apparent displacement D produced by a transparent block made of the material of relative index, refractive index N and thickness H, placed in air when an object O is placed at the opposite side of the block as shown in the figure. We have to write the equation for apparent displacement. Apparent displacement D equals T times 1 minus 1 over N. It is the equation we have derived. But in this question, they have given that thickness of the material plastic block is simple H. We have to substitute H as the T value, 1 minus 1 over H. In part B, as in figure 2, the small pin O is placed at the bottom of the empty cylinder. The travelling microscope is focused from above to view a clear image of O, and the reading is taken, say X. Then the liquid is produced, so poured up to a certain height H. Part 1, what should do to the travelling microscope to see clear image of pin again? Let the microscope reading be Y in this situation. We know that there is a displacement, there is an apparent displacement for the object when poured liquid into the cylinder. The apparent displacement is in upward direction. Therefore, we have to move travelling microscope in upward direction. Part 2, write down the experimental steps that you follow to measure the height of liquid column. Let the reading is to be Z. They have given fine plastic pieces which can float on the liquid and large syringe. We have to float plastic pieces on given liquid. First step is float plastic pieces on liquid, and we have to focus travelling microscope to plastic pieces. Focus travelling microscope to plastic pieces. Now reading is given as it is. Now I will explain the method we have to use. In the cylinder, first of all we have to place the pin at the bottom of the cylinder, pin O. And then we have poured liquid into the cylinder, and we have obtained second reading when focusing this original object O. Now object is in this space. It means there is a displacement. There is an apparel displacement. Now there is an image at this space. Then we can get, when focusing O image, reading is given as X. When focusing I image or object X, I image Y. And then final step, we have to plot plastic pieces on what, and when focusing plastic pieces, reading is Z. Now we can get apparel displacement is this value, X, Y minus X. Difference between Y and X. And real depth is gap between Z and X. We have to subtract Z and X to get real distance. It means height of this liquid. Now part 3. Write down the expression for height of liquid column and apparent displacement D of the image using readings X, Y, Z. We can write height of liquid column Z minus X and apparent displacement is Y minus X. Part C1 is the expression you have written in part A. Above is used to determine the refractive index of liquid NL using a graphical method. What is the variable that you are going to change in it? Now we have to decide the variable we can get easily. It means we can change values easily. We have to change simple H. We can pour liquid into the cylinder. Then part C1. Simple H is the independent variable. Part 2. What will be the dependent variable of the straight line graph that you are going to draw? We have to change H value and we have to measure D. Then D is the dependent variable. D is the dependent variable. Or we can write H is height of liquid column, D is apparent displacement. Clearly labeling the axis, sketch the graph you would expect. We can get the equation D equals H into 1 minus 1 over NL. Then using liquid we have to substitute N as NL in liquid. In this part we have written the apparent displacement for the given plastic block. But we have to use liquid. Therefore, NL value is the refractive index of liquid. Now we can get D equals 1 minus 1 over NL times H. It is in the form Y equals mx. X value is H, Y value is D. H is the independent variable, Y value, D is the dependent variable. We have to get dependent variable to the y-axis and independent variable to the x-axis. Now we can draw the rough sketch of graph. It is in y equals mx plus mx form. A straight line passing through the origin. Y-axis is D. D is measuring in centimeters. We can get centimeters. X-axis H in centimeters. Or you can use SI unit, meters, but normally we have to get centimeters because of we can't change H value in meters. Then part D, obtain an expression for the refractive index NL in terms of gradient of the graph. Now we know that this part is the gradient of the graph. Then we can write gradient equals 1 minus 1 over NL. We have subject NL. I will bring 1 minus NL to this side. 1 minus gradient. Then we can get reciprocal. NL equals 1 over 1 minus N. Part E. If the gradient is 0.2, calculate the value of refractive index of liquid. We have to substitute gradient value for this equation. NL equals 1 minus 1 over 1 minus, gradient is given as 0.2. 1 over 1 minus 0.2, 0.8. NL equals 10 divided by 8. We can divide by 2, 5 over 4. 5 divided by 4, 1 remaining. 1 and 1 over 4 or 1.25. Refractive index of liquid. When the height of the liquid column is 5 centimeters, water is slowly poured so that liquid floats on water. The total apparent displacement of the image of the pin 1.5 centimeters and the refractive index of water 4/3. Calculate the height of the water column in the cylinder. Now we have to consider sum of apparent displacement. I will draw a diagram. Now there are two layers. They have given that liquid is floating on water. Liquid is floating on water. Slowly poured, water is slowly poured so that liquid floats on water. In water, liquid. Now original pin is at this place, object pin. Now when see the object from this place, there are two displacements. There are two apparent displacements. We can consider apparent displacement from water is D1, apparent displacement of liquid is D2. Then total apparent displacement means D1 plus D2. Total apparent displacement is given as 1.5 centimeters. We can write D1 H1 into 1 minus 1 over NW. NW means refractive index of water. Plus H1 is this height, water height. H2 is liquid height. Then we can write apparent displacement by liquid is H2 times 1 minus 1 over NL. Then we have to substitute values. 1.5 equals H1 is water height. We have to find it. Then I will use H1 minus refractive index of water is 4/3. They have given in the question, but we have to use reciprocal 3/4. Plus H2 value is liquid column 5 centimeters. It is given in the question. 1 minus. We know that we have found NL as 5 divided by 4. Reciprocal 4/5. Then we can simplify and find the value of H1. 1.5 equals H1 multiplied by 1 minus 3/4 means 4/4 minus 3/4. 1/4 plus 5 multiplied by 1 minus 4/5. 1 means 5/5 minus 4/5. Then 1/5. We can cancel out 5. Then bring plus 1 to this side. We have to subtract 1. 1.5 minus 1, 0.5 equals H1 into 1/4. Then we can find the value of H1, 0.5 into 2, 5 into 4. Then answer is 2 centimeters.